Hey everybody, Dr. A here, and in this video we're going to be providing some background information and going through some simple examples and investigating the determinacy and stability of multi-story frames. So let's go ahead and get started. First of all, when we think about a multi-story frame from a determinacy and stability perspective, we characterize them by what we call their loops. And again, we're doing this really for the sake of determinacy and stability. So when we say loops, what we mean is each enclosed story will be like a closed loop, okay? And so what we do is we make a vertical cut through the frame loops and draw a free body diagram of each sectioned part. So then there's going to be three unknowns, which are the unknown loads, a moment and two forces at each cut, okay? So that means R equals 3 at each cut. So let's take a look at this illustration here. Here we have this two-story frame that's fixed connected at its base, and you see, you have two loops because you have two stories, two enclosed stories. So this is loop 1 and this is loop 2, all right? And so what we do is we make a cut through the loops like this, and we separate this into two pieces. So let's go ahead and do that together. We're going to make this one cut here and look at the left piece, and then when we cut it, we're going to have a right piece also, all right? And so we'll make these little cut symbols here. And then what we do is we expose the reactions or the internal loads that become external at that point. So at the fixed connections, we've got horizontal and vertical force and a moment at each fixed connection, at each external fixed connection. And then at these cuts, similarly, you're going to have vertical forces that are equal in magnitude and opposite in direction at each cut. And then same thing with horizontal forces, equal magnitude and opposite direction at each side of the cut. And then moments, equal magnitude, opposite direction on each side of the cut, okay? And so when we count these all up, we count each cut as exposing 3, okay? Even though we see them show up as 6, but remember it's the same magnitude on each side of the cut, but opposite direction. So that only counts as 3, okay? So if you see here, we got 3, 6, 9, 12. So we're gonna say R equals 12, N equals 2, and 3N is gonna be 6, okay? And so this is gonna be statically indeterminate. And what's the degree of indeterminacy? Well, that's going to be statically indeterminate to the 6th degree. If you remember, what we do is we say R minus 3N, and that gives us the degree of indeterminacy. So that's this first kind of illustration slash example. So let's now jump into more explicit examples. So here we're being asked to classify each of the frames as statically determinate, indeterminate, or unstable, and state why in each case. So on frame A, we're going to make this cut through these loops. We have 3 loops here technically, and we're going to separate it into 2 free body diagrams. So let's go ahead and do that. Let me change colors back to black here to be consistent. All right, so we've got these 2 levels here. Then similar on the other side, okay? So, you got these cuts on either side here. And then we are going to show these external reactions. So we have a pin connection here, vertical and horizontal, and a vertical reaction at this roller. And then similarly, like we saw in the previous page, we have horizontal and vertical forces that develop at each side of this cut, equal in magnitude, opposite in direction, okay? And so when you count these up, what do we have? Well, again, you have 3, 6, 9, 10, 11, 12, okay? So here, R is going to equal to 12, N is equal to 2, 3N is 6, and so this is statically indeterminate with a degree of indeterminacy of the 6 degrees. So statically indeterminate, okay? 6 degree indeterminate though. What about this frame in B? Okay, well here you have 2 bays. So we're actually gonna make 2 cuts, one through here and one through here. And we're gonna separate this into 3 pieces, okay? So let's do that one at a time, okay? So that left piece, when we make these cuts, I always forget to change the color back. Make these cuts, we've got this piece. We have this piece. And we have the third piece here, okay? So then we're going to show, 2 force reactions, one vertical, one horizontal at each one of these cuts on each side, plus a moment, equal and opposite on each side. There's the verticals, horizontal, moment, and the external reactions at that pin. We got 2 force reactions. At the roller, we've got 1, and then at this fixed connection, 2 force reactions plus a moment. So we're going to add these up again: 3, 6, 9, 10, 11, 12, 13, 14, 15. Okay, so here R is going to be 15. 3N is going to be what? Well, this is going to be 9, right? Because we've got 3 parts. We have part 1, part 2, and part 3. So 3 times 3 is 9. And so this is going to be statically indeterminate, of course. And what's the degree of indeterminacy? Well, we say 15 minus 9. So that's to the 6th degree, right? And then the last frame we have in our example is this one that has some kind of angled members. Plus, it also has this internal hinge here. Okay, so remember what we do for internal hinges. We always disassemble at the internal hinge. So we're really only going to make 1 cut here, but we're going to disassemble at the internal hinge. So what is that going to look like? Well, that leftmost piece is going to look like this. Change colors back again. It's going to look like this. We have this disassembled piece here. And then we have this kind of middle piece. Draw that a little bit better for us. Now that middle piece is going to be a result of, the cut and the disassembled hinge. So we have this cut here and here, which comes from the cut we made through this, all right? And then we have that rightmost piece, which again comes from these cuts. Let me see if I can do this a little bit more with a straight edge. There we go. Cut. And we're going to have force reactions, moment reaction here. Now, what shows up at an internal hinge? Well, just 2 forces, a vertical force and a horizontal force with equal magnitude and opposite direction. No moment happens when we disassemble at an internal hinge. But at these cuts, we do see both vertical, horizontal, and moments develop. Okay, and don't forget the rest of the externals. We have a roller, vertical reaction, another vertical reaction at that last roller. So here, what do we have? We have a number of reactions. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So R is 13, N is 3, 3N is 9. So this is statically indeterminate, and the degree of indeterminacy is what? 13 minus 9, 4th degree indeterminate. Okay, so that concludes this example video and background information. If you found this helpful, please hit like and subscribe, and be on the lookout for other content like this. Thanks for watching.